Okay, so we are going to be starting chapter 7, equilibrium. Now, in chemistry, we did actually go over equilibrium. It was at the very end of the year. It was very brief. So hopefully when we're kind of doing this, it'll kind of spark in your head like, oh yeah, I remember doing this. So reactions are reversible. Okay, they just don't go one direction. Okay, now usually in chemistry, we think about them only going in one direction because it's much easier to think about it that way. It's much easier to observe that. But basically, reactants are becoming products, but products, as they're building up, are going to become reactants. So initially, we start with only A and B. So originally, we only have reactants. So only the forward reaction is possible. Okay, because we don't have any products to then go back to reactants. Okay, so as C and D, which are our products, build up, the reverse reaction is going to speed up, which means it starts going in reverse. Okay, and the forward reaction is going to start to slow down. We're going to look at this graphically. It kind of makes more sense looking at it graphically. So eventually, the rates are equal. Okay, and the rate just means the rate of change at which a product is becoming a reactant or a reactant is becoming a product. So this is equilibrium. So here we have our graph of the reaction occurring over time. We have the concentration of each of the species. So for this one, our reaction is A plus B yields C. Okay, how did I know that? It's because I'm starting with A and B. There's no C. So my reversible reaction is C. So C is my only product. So over time, we see that the concentration of A and B drop, but the concentration of C increases until they level out. Okay, so at T1, so sometime, this is our equilibrium time, the concentration of all three species stops changing. Notice, they're not equal, okay? The concentrations are not equal, but they're not changing anymore. So that's the big thing that people get confused with. They're like, equilibrium, okay, they're all equal. Not true. It just means they're not changing. The rate at which they're changing is equal, so that when reactants become products and products become reactants, nothing really changes in terms of, it's like me handing you $1 and you giving me $1. We each still have $1. Right? Okay, so the reaction has not stopped. It is in dynamic equilibrium. Okay, so even though the concentrations are not changing, okay, reactants are still becoming products, products are still becoming reactants. So again, the dollar changing. We're still exchanging dollars, we're just not changing how much money we each have, okay? Even though we're still exchanging money. So the coefficients tell how much a species concentration will change prior to the equilibrium. Okay, so if we look at all of these, this one goes from 4 to like 4.5 or 3.5, no, 2.5. Okay, this one goes from 3.5 to 2. This one goes from 0 to 1.5, so they're all changing. By 1.5 molar. Okay, thus, our coefficients are all just going to be 1. They're going to be equal. That makes sense? Okay, whereas if we had one that dropped faster, okay, that one would mean it would probably have a coefficient of 2. Okay, so at equilibrium, there are more reactants than products. Okay, we can just see that, right? We have more of A and B than we do of C. So even though this proceeded forward, we still have more reactants left over than the products that were made. Okay, so that kind of brings us into equilibrium constants, which is kind of the main point of this unit. So the relevant amounts of products and reactants present an equilibrium and are expressed with the equilibrium constant. Which is K. It's just a ratio, which means there's no unit. It's just the ratio of products to reactants, and it just lets us know how favored something is. So a large K means products are favored, okay, because we're going to see it's products over reactants. So if we have a lot of products, okay, we have a large numerator, we're going to have a larger K. While a small value means reactants are favored, okay? We're going to see lots of different equilibrium constants. You'll see each of the subscripts, they represent different types of conditions. Most of the time we're going to see Kc. This is concentration, okay, or molarity. So if they give us molarity in a problem, we're going to be using the Kc. Remember that molarity is equal to moles over liters. Sometimes, a lot of times, we have to convert the milliliters into liters by moving the decimal 3 times. Okay, the next one is pressure. Okay, so this is when we're dealing with gases. We're going to use pressure. Okay, today we're going to talk about these two. The rest of them, I think we talk about SP in a later chapter. Is that right, or is that the next chapter? I don't remember. No, we do. But A and B we'll talk in a later time. So SP is solubility, product. Okay, so if we're dealing with a solid that is being dissolved, we use that, which we will do in a later lesson in this unit. And then A is for acids, and B is for bases. Okay, and specifically the dissociation of each. Remember, dissociation just means the dissolving. Okay, but specifically as a liquid, they're breaking up into their ions. Okay, so when we are writing the K expression for our equilibrium constants, here I've given 2 examples, whether this was concentrations that were given or pressures that were given. This is our generic equation. Again, we've done this before in chemistry, it's just we did it really quickly. Okay, so we have our A species with a coefficient of lowercase a plus our coefficient B of species B. These are our reactants, and then we have our products C and D, okay? So notice that when we're writing our Kc expression, we put in brackets each of our species of products, okay? And we raise them to the power of their coefficient. And then on the bottom, this is going to be our reactants, okay? We see the same thing here. They just use a slightly different notation. So instead of brackets, we use parentheses, okay? And instead of just putting the species, we put P of C, so pressure of C, pressure of D, okay? So slightly different, but sometimes they do ask you questions like that. They try to trick you on the test. They'll give you a gas situation. They'll put this in there. Well, this one's the correct one. Okay, so sometimes they do try to like catch you out of that. So let's practice with an actual equation. So here we're going to do it in terms of concentration and we're going to do it in terms of pressure. I know it did give us a gas, but sometimes with gases they will give you the concentration of the gas instead of the pressure of the gas. Okay, so for this we're going to do products over reactants. So my product is NH3. When I'm doing my concentration, I use brackets. So I'm going to have my NH3 raised to the second power because of the coefficient, divided by, and then my reactants, okay? Notice that we're not adding or anything like that. We're just multiplying each of the reactants. Okay, so my N2 is one of the species. It's raised to the first power because it doesn't have a coefficient out in front. And then we have H2 which is raised to the third power. Okay? For our pressure, similar, except we're going to use parentheses, and it'd be the pressure of NH3 squared divided by the pressure of N2 to the first power, and then the pressure of H2 to the third power. Okay, so pretty straightforward. You just have to pay attention. What kind of conditions are they giving you? Are they giving you molarity, or are they giving you a pressure like atmospheres? Okay, when we are determining the expressions, pure solids, which is our S, and liquids, which is an L, are left out of the expression. So we're going to go through and do the Kc for each of these with that new information. Okay, so remember, we're not going to use solids. So this is going to cancel, this is going to cancel. We're not going to include those. So our Kc is products. We have one product that is a gas. So since we're using Kc, we're going to use brackets. So CO2, and it is to the first power. Wait, is it balanced? Okay, divided by, do we have any reactants? No, so just be 1. Okay, so usually when you write this, you would just write Kc is equal to brackets CO2. Okay, for the next one, this is a solid, this is a solid. So my Kc is equal to, do I have any products? No, so it'd be a 1 over my reactants. I only have one reactant, so brackets O2, and it's raised to the first power. Okay, do you vaguely remember doing this? Okay, I was going to say, do you vaguely remember this? All right, so let's actually look at using numbers to calculate. Yeah, it's a lot. It's not a lot, it's just, it takes up a lot of page. Okay, so the reaction above takes place at 300 Kelvin. Okay, temperature is irrelevant unless it's changing, and it will never be changing for these types of elements. Okay, and it's allowed to reach equilibrium. So the equilibrium concentrations of CO2 and CO are 2.5 molarity and 0.35 molarity, respectively. So they're telling us concentration, they're telling us molarity, so we're going to find Kc. So first, for part A, it wants us to write the equilibrium constant expression Kc. So our Kc is equal to, what's our first product? CO2, we're going to put that in brackets. It's raised to the first power. Do we have another product? No, because this is a solid. A divided by reactants. I have one reactant, which is CO, and it's raised to what power? 2. Okay, so that's our equilibrium constant expression, or equilibrium expression, sometimes is what it's called. So then for part B, it wants us to calculate the value of Kc at 300 degrees Kelvin. So for B, we're just going to plug in the information that it gave us. So our Kc is equal to, our CO2 is 2.5 molarity, divided by, my CO is 0.350, and it is raised to the second power. We're going to give 3 sig figs. Okay, 300 Kelvin is only 1 sig fig, but it's not utilized in the calculations at all. We only are using these two numbers. They each have 3 sig figs, so we're going to report 3 sig figs. So we get that our Kc is equal to 20.4. Okay, is this a large or a small Kc? It's large, because large is anything over 1. Okay, so this is large. What is it favoring? If it's large, products, right? I have more products than I do reactants. So this favors products. It just means that at equilibrium, I'm going to have more products than reactants. Okay? For this next one, the reverse reaction of the above reaction. in a rigid 2-liter container, and a total pressure was monitored as the reaction proceeded. We're going to write the Kp, so this time we're going to be using the parentheses and then the P of whatever. Okay, we're going to calculate the partial pressure of CO gas at equilibrium if the partial pressure of the CO2 is 1.63, and then we're going to determine the equilibrium constant value. Okay, so first off, we do need to figure out the reaction. Did I write it down? Yes, I did. I don't know why I didn't. Weird. Okay. Well, it's CO2 gas. Or is it on yours? No. Okay. CO2 gas plus carbon solid yields 2CO gas. Okay, so that's our reaction. That should have been on there. I need to make a note of that. Let's put it in. Is it above?
Well, it just says reverse it, so you just.
Oh, it is. Yeah. Okay. Good. I'm glad you guys are more on top of it than I am. Okay, so for our A, we're gonna write our Kp. So what's our product? Yes. So we're gonna have the pressure of CO squared divided by pressure of what? Pressure of CO2 raised to the first power. We're not going to include the carbon because it's a solid. Okay, so A, done. Okay, for part B, calculate the partial pressure of carbon monoxide if the partial pressure of CO2 is 1.36. Okay, so if we look at the data that's been given to us, what pressure is equilibrium met at? When is it reached? 8.37, right? Because it's not changing. So we're at equilibrium. Okay, so it's at equilibrium because it no longer is changing. So that's our final pressure. So for part B, I'm going to take my final pressure minus the partial pressure of CO2 to find the partial pressure of CO. Does that make sense? Because there's only two gases. There's only two gases in the tank. So if carbon dioxide is 1.63, I know the total pressure is 8.37. I would just subtract that. So the pressure of CO is 6.74 atmosphere. So I did the 8.73 or 37 minus 1.63. Okay, so for part C, we're now just going to plug in that data into the thing. Why? What are we lost?
No, I'm not lost.
Okay. Are you sure? You're the what?
We're leaving being lost in Chem II in 2025.
Nice.
New Year's resolution. Yeah.
Well, I'm not going to ask questions if you get lost. Okay, so they told us the pressure of CO2, so we can plug that in here. We just calculated the pressure of carbon monoxide by subtracting it from the total pressure. So we're going to plug that in here. So we're going to have our Kp is equal to, our carbon monoxide was 6.74. We're going to square that. Okay, usually people forget like their squares and stuff. That's usually whenever they mess this up. And then our CO2, they told us in the problem was 1.63. So then we just math. We're going to do 3 sig figs to get 27.9. So what does it favor? Products. Which means that at equilibrium, we're going to have more products, meaning more carbon monoxide, than we do reactants, so the CO2. All right, last thing for today. So those were all our equilibrium constants, which are K. We also have the reaction quotient. The reaction quotient, which is Q. So this tells us the relative conditions at any moment during the reaction. Usually it's the initial conditions. Okay, so usually at the start of the reaction, A, blah, 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 blah.
I thought he was caressing the door the whole time. He had his arm up the whole time. Thought he was like sensing the force through the door or something. I was really confused.
No, you're fine. Is it getting moved? Oh, okay. Okay.
Dude, I have nightmares about school all the time. Genuinely. Like nightmares when I'm failing a class.
All right, so
I haven't done
Q basically helps us figure out what is going to happen with the reaction. Is it going to move forward? Is it going to move reverse? Okay, we did do this in chemistry as well. So Q equals K. Do you remember that? You might. When I say it, you might remember. So this means it's already at dynamic equilibrium. So it's not going to shift either way. It's already at equilibrium, so it's not going to move in either way. The conditions are not going to change. Okay? If Q is greater than K, it's going to proceed reverse. Okay? Meaning that more reactants are going to be made. On YouTube. Okay, so for this one, what I say is if Q is bigger than K, it went too far. It went too far. It's got to come back. Okay, so it's going to go reverse. So we have K. K is our perfect condition. So if Q is bigger than K, it went past it. It's like a finish line. So it needs to go back to meet K. Okay, so it's going to go reverse. Okay, if Q is less than K, it's going to proceed forward, which means more products are going to be made. Okay, so this one, Q needs to catch up. Okay, it hasn't reached K yet because it's under K. Does that make sense? So if Q is greater than K, it went too far, it's got to come back. If Q is less than K, it's got to catch up to K, so it's got to go forward. Go for it. Go for it. Q is bigger than K and went too far. That's fine too. All right, so let's practice. A mixture contains the same amount of both gases at standard temperature and pressure. What's standard temperature and pressure? 1 atmosphere, 0 degrees Celsius. Yes. Okay. Remember, temperatures are relevant, right? So it tells us that the Kp is 1.5. So we need to find at this situation, how is the reaction going to proceed? Okay. So first off, let's write our Kp because they're telling us pressures. So we're going to write our Kp for this. Our product is N2, so it'd be P. I know. And it's going to be squared, right? These are the two coefficient.
Yeah.
And then we have one reactant, so the pressure of N2O4, and then it's just to the first power because there's no coefficient there. Okay, so it says it contains the same amount of both gas, okay? We're just going to use the pressure that we're at, which is just 1. So we're just going to plug 1 into it, right? So we're going to have 1 squared over 1, which is just going to give us what? 1. So our Q value, this is Q. Sorry, I wrote this wrong. This was QP, not KP. Sorry.
I'm back to stress. Everything's ruined.
I know. Okay, so Our Q is 1. Our K is 1.5 from the problem. So Q is less than K, so it has to catch up, so it's going to go forward. It's got to catch up, so it's got to go forward.
Noah, do you want to come scold with us on the video?
That's it.
Okay. No, wait. Never at school.
Right. Get to school now.
This is
ruined.
ruined.
It's already clicked
This
off.
is
Your parents are gonna go to jail.
Wonderful.
That was great, guys. Good work.
All right, let me post your guys' assignments.
Luke, this is the second
Actually, it will. I was going to say we're doing it all week.
The second day we told you need to get to school.
Fifth hour is gonna dislike this.
Why is he?
I just want to say.
More of a
I'm not. Guys, this is fun. I say this until we
This is all review. We've already done
Wait
this.
till you get to
I
the
hate when you
hours
say
and
that.
it makes no
I
sense.
did this 2 years ago. I don't know anything
I
about
like
chemistry.
review. I like review.
Well, I generally always suggest to people, like, if they're thinking about doing Chem II, to do it right after chemistry.
Yeah,
'Cause it is
and
helpful.
they did, and I said, no, I'm gonna take an
Mm.
And then last year I was like, oh, I guess I'll take Chem 2. Why not? I need
Yeah.
to class.
Plus, like, taking Chem 2 as a senior, it's like... Although, all fourth quarter, we don't really do
I
anything,
just hate
so...
my life, is what's happening.
Yeah.
Dude, yeah, I know, and I'm gonna be in stats this semester.
In past year... I don't know why this is taking so long.
Hey, where'd
In
you get
past
stats?
years, I've
Okay.
I've had students take chemistry, Chem 2, and physics at the same time.
I'm still in the fifth hour chemistry classroom, which I probably will be back there tomorrow. But
Okay, well, I'll just leave you and we'll see.
I walk up middle sidewalk, I go that way.
Because I post both of them at the same time, so...
Go in, right? You're gonna walk down. You're gonna get to that hallway.
I promised Miley I had to be back.
It's the
So
first door on the right.
I do not want to take stats, guys. Actually,
Well-
FML.
then don't.
Literally,
Okay,
Drop out.
Counselor for real didn't even ask me. She was like, you're gonna be in stats and intro logic. Is that okay?
So I actually
Hey,
don't
she
know what
asked
class
you.
I
She
guess.
asked you if you were
So
fine
I'm
with
actually,
it.
I don't know what class I'm in this semester. At all.
You had to sign something.
Yeah.
Did she not grab you? No. Oh yeah, she kidnapped me and Chloe out of the hallway.
Yeah, you had to sign a paper. It's like, I agree to this. Yeah.
Did your parents pay tuition?
For what classes?
I'm signed up for Link. I think I am.
Yeah.
I'm confused.
If you pay for the classes.
I would just email.
Alright, they're posting.
I would email what's her name.
Ada? Or Archibald?
The lady
Dog.
who's always here with me. Where are you confused? Just email somebody.
Oh,
I'm
wow. Log
confused
in.
because I go on my LinkedIn Land account. I can get in. I go and it says I'm not registered.
Oh no. Anybody studied for any of the AP tests yet?
I've started.
Oh.
But that's just because I'm really
All of fourth quarter, that's what we do. Those are all your assignments. They're just like practice exams.
Question 1 is C.
Hold on, guys. I'm not. Like, it's not.
Hey, like, she's still getting there.
Guys, wait, like.
Pause.
Okay.
I think it's B.
It's C, right? This is taking a toll on her.
I don't even know.
not you guys.
Oh no, definitely not.
I'm just imagining like all my trials slamming in the background.
I don't understand
the
where
song?
C is.
When did you guys start musical practice?
I hate everyone.
You're asking.
So it's really funny. I was gone both days that the musical trials were, and I was gonna do the musical.
What part did you get?
Hello?
Matilda.
Hey, what are you doing?
Nickel Mayor.
Not the lead? Okay.
No. Guess who got it?
Ella Hornstein or Olivia Garrity?
Kendall.
Oh.
Morning.
One
Okay,
girl that's
sounds
dating
good.
the girl is really older than her.
Yes, question 1 is C.
Okay, bye.
20 questions. Oh boy.
What grade is she in?
She's a sophomore, but last year her girlfriend
sophomore?
graduated.
Getting the lead.
And Ella got a secondary.
But that was Annie.
Ella got a secondary lead in 8th grade too.
Yeah.
Okay, we're gonna name this what?
I don't even care anymore. Let's just watch it.
Happy birthday.
Unit.
Guys, I haven't watched the new movie yet.
Fun.
Oh, that
The concept.
freaked me out.
New movie.
Five Nights at Freddy's.
I liked it. I'm not gonna lie. Like everyone thought it was bad, but like